So hey everyone, from this video onwards we are going to understand the sorting algorithms. Okay, so what are the sorting algorithms? So basically when we have a sorting task to perform, so which algorithm do we actually perform in order to sort the particular element? So the elements could either be numbers or they can be even characters. So what algorithm do we apply to sort those numbers or characters is what we call as sorting algorithms. So basically there are many sorting algorithms, so based on their performance and trade-offs, so we categorize them into 5 most popular sorting algorithms, so which is the bubble sort, insertion sort, selection sort, merge sort and quick sort. So in this video we are going to get started with the most popular yet the least efficient sorting algorithm, that is bubble sort. Okay, so let's understand them one by one. So in the subsequent videos we are going to understand the other sorting algorithms as well, and what are the trade-offs that we have between these sorting algorithms. So every sorting algorithm has its own trade-offs, which means that one is best in doing something but not good in something else. So we are going to understand that as well, which exact sorting algorithm do we apply for different types of problems, and also based on the understanding how easy it is to understand. So let us start with the bubble sort. So I have considered here an example of 5 numbers which are currently unsorted, but we need to sort them using the bubble sort. Okay, so how does the sorting algorithm actually work? So first we need to pick first 2 elements from the current set of numbers, so that is 8 and 5. Now we need to check which one is greater. So if 8 is greater than 5, then we swap these 2 numbers. Okay, so we swap 8 and 5 over here. So these two get swapped, and then we go to the next 2 numbers, so that is 8 and 9. So now we see that 9 is greater than 8, so we do not do the swapping over there, and then we go to the next 2 numbers, 9 and 2. So now we see that 9 is greater than 2, so we swap 2 and 9 values. So if the next number is lesser than the previous one, then we swap, otherwise we let them be as it is in their own place. Okay, so now we see that 9 and 6, which one is greater? 9, right? So we do the swapping. So now if you observe, so the 9 was previously at the third position, so this keeps on bubbling up till the exact position where it has to be found. So that is why this algorithm is called as bubble sort. Okay, so now we keep doing the same thing again and again. Okay, so unless we find that the whole array is sorted. So this is just the first iteration. Then we again do the same, 5 and 8, which one is greater? So 8 is greater, so we let them be in its own place. So now we check that 2 is lesser than 8, so we do the swap over here, and again 8 is greater than 6, we do the swap again, and so again we keep doing the same. So 5 and 2, which one is greater? 5 is greater, so we do the swap. So basically the left element is greater, and then we check 5 and 6, which one is greater? So 6, the leading number is greater, so we keep it as it is, and then 6 and 8, so everything is now sorted. So this is how the bubble sort operation is performed. So the advantage is that it is easy to understand and implement as well, but when it comes to performance, it is the worst because it achieves a time complexity of O of n square. Okay, the reason why is we just need to keep swapping elements again and again. Okay, so since you see that the first time we complete the sort, but we still saw that the array was unsorted, so then we just do the sorting again, so it would just be the time complexity of O of n square. So we just keep doing it again and again based on the size of the numbers array, so that is why this becomes a lot inefficient. Okay, so this is just 5 numbers, so it doesn't matter in terms of performance, but when we have a large set of numbers, the time it takes to do the sort operation keeps on increasing exponentially. So that is why we get the time complexity of O of n square, and we do not create any additional data structure for sorting, so the space complexity remains as O of 1. So the name comes bubble sort because the numbers keeps bubbling up and until it finds its place. That's where the name comes. So I hope you understood the exact sorting algorithm about bubble sort. Let's now understand how can we code this practically in JavaScript. So this is a function called bubble sort which takes in an array of numbers to be sorted. So we can just get started by initializing a for loop, and we just want to set 2 pointers, so one is at here and here, and we just need to check if which one is greater. So if the next number is like lesser than the previous one, then we just want to swap them, else we just want to skip the iteration. Okay, initializing I, so basically the first iteration value, so setting I equals 0 and I is less than array dot length, and then incrementing I. So inside that we create another for loop for the j element. So let's say for let j equals 0, and then j again is less than the array dot length minus I minus 1. The reason why we are doing this is, so after I elements the array is already sorted, right? So all the other numbers are sorted, so we just don't want to check for them for those numbers that are already sorted. So we just want to subtract that by minus I minus 1. Okay, and then we just increment j. So now we need to check if the current value is greater than the next value. So let's put a check at array at the value of j is greater than the next value. So then we just do the swap. Okay, so there are many ways you can use to swap elements. So either you can use the temp variable to store the temporary value and then swap the two elements from there, or you can use the modern way of swapping two elements, that is initializing an array and set that to another array where the elements that are there within this array gets swapped within this. So basically the elements from this array gets swapped from this array. So we just set array at j and j plus 1, and then the value of the next array is going to be first the j plus 1 and then array at j. Okay, so like this. So basically here the elements are getting swapped, and then finally we return the array after the complete iteration. So let's return the array. So now if I run this file, so we should be able to get the array sorted. So you see that now our array is sorted. So we pass in 5 4 3 2 1 and we get 1 2 3 4 5. Okay, so just for testing I can just add in another number. So let's say 10, and now I run this. So you see that 10 is also sorted in the right place. Okay, so this is how you can implement the bubble sort. As I told you, this is not the efficient solution as we are creating nested for loops. This gives us a time complexity of O of n square, which is not at all efficient. So currently we just have few elements within the array. So if you are having a large element, so it takes a lot of time to sort it. So this is the most simplest sorting algorithm, yet it's yet it's the least efficient as well. So they might ask you this in interview questions. So this is one of the most popular interview questions, that is to implement a bubble sort. So you can just implement in this way, and if they ask you this in interviews, I hope you should be able to solve this. Okay, so I hope this explanation could help you do that. And yeah, so that's it for this video. So we'll see in the next video how can we implement the next sorting algorithm, that is insertion sort. Okay, so thank you so much for watching. Make sure to subscribe. I'll see you guys in the next video.